Alright, man, recording this over and over again is pretty stressful and annoying. Alright, I'm gonna try to get this right this time. Alright, let's take a look at jump game 1 and 2. And actually, jump game 2 is number 45 on the website, and jump game 1 is number 55. And I'm guessing because jump game 2 is the more commonly seen, more popular software engineering algorithm questions, so they probably uploaded this to the website first, and then they came in and added an easier version of it later on. But anyways, we're gonna look at how to do both. And to do jump game 2, you'll build upon what you did in jump game 1 somewhat. So okay, yeah. So jump game 1, you're given an input list of jump sizes. So each number here represents the max jump size you can take from that current index, and you want to see if you can go from the starting index to the last index successfully. And yeah, so if you can, you return true. If you can't, you return false. Okay, so let's look at why this is true. So from this 0th index, our max jump size can be 2. So we can jump size 1, or we can jump size 2. So we can reach the 3, or we can reach the 1 here. And then from this 3, we can jump either size 1, 2, or 3. So you can jump up to size 3. So you can jump to here, or jump to here. And so, if we can jump to here, then we should just return true. Then looking at example 2, we cannot reach the end index, and let's see why. So if we're at index 0, then our max jump size is 3, so we can reach the 2, the 1, or the 0. And then so if you're at index 1, your max jump size can be up to size 2, so you can jump to here or here. And then at index equals 2, then your max jump size is 1, so you can only jump to here. And then, as you saw in the previous 3 jump size locations, you're always going to end up at the max jump of here. So you're going to be stuck in this trench, and there's no way for you to get to the last index. So let me show you a easy O of n greedy approach, which also has constant space, so O of 1 space. And all you need to use is just a max reach variable to hold the max index that you can reach. So that's what this represents, the max index that you can reach. Okay, so we're going to just go through and try to update the max reach to whatever it is, the maximum index that we can reach. And so at index 0, I equals 0, the value is 2, so the jump size of 2. So our max reach is 2, right? Because we can go to index the value of 3 or the value of 1. And the value of 1 is at index 2. So that's our max reach. And then we're going to update it once we go to the next index. So when index is 1 and the jump size is 3, then 1 plus 3 is 4. So our max reach can go up to 4. And so once our max reach is greater than or equal to the index at the last index, and let's just say this was 1 or something. So the last index is index 4. And so once our max reach is greater than or equal to 4, then we can just return true and terminate early. So that's what happens in this case. So then let's take a look at the example where we can't reach the end. What's going to happen is we're going to have max reach equals to 3, and then we're going to move the pointer, and then so I equals 1 and the value is 2, so 1 plus 2 is 3, so max reach is still going to be 3. Same thing for here, I equals 2 and nums equals 1, so 2 plus 1 is 3, so max reach is still going to be 3. And then same thing here, so I equals 3 and the jump is 0, so 3 plus 0 is 3, so max reach stays the same again. And then once we get to here, I is equal to 4. And once I is actually greater than the max reach, then we should return false, because what this is saying is if the max reach up until this point was only 3, then there's no way we could actually be even looking at index 4 right now, so we should return false. And so that logic will also hold true if the starting point was 0. So this is actually considered a edge case, but in our logic, and I'll have the code in the description so you can see the way I implemented it, but the way I did it is, we're just going to handle this in the same case as the one above, and that's just going to be, so if we're at this index, I equals 0 and the jump is 0, so max reach is 0, and then once we get to I equals 1, 1 is greater than the max reach, so it'll just return false here. Alright, so let's move on to jump game 2 now. So let's see what differences there are in the problem description. So we're still given the input list of the jump sizes, except this time our goal is to find the minimum number of jumps to go from the start to the end. And actually we're told that you can assume that you always can reach the last index. Excuse me. So that makes it a little bit easier for us. So that's good. So let's take an example. Let me first preface this by saying that we're going to kind of go through this problem, and it's labeled a greedy problem, and it's you can kind of consider a greedy algorithm, but the way that we're going to view this list, this input list, is we're going to view it like it's a breadth first search. And in a breadth first search, if you recall, like doing binary trees, or if you're familiar with grid traversal with the breadth first search, what you do is you traverse level by level, right? So if you're at the starting point, then all the children will be in level 1, and then all the children of those children will be considered level 2. So similarly, we can kind of treat the jumps as levels, and everything from the starting point is level 0 or jump 0, and then everything below that, everything we can get to from the first from the starting point will be considered jump 1, and then everything we can get to from jump 1 will be considered jump 2. So that's how we're going to view this problem. And so the kind of naive approach is to do n squared, where basically for each of these, so if we're at the starting point, then we have everything below it, which is jump 1. Then we're going to iterate through everything in jump 1, and then try to update a max reach variable, and then we'll do the same thing for everything in range 2. We'll have to iterate through all of those again. And so the reason it's going to be n squared is because when we iterate through this range, so we're going to keep track of each level with this reach range, we might have to actually iterate through and reprocess some of the same elements more than once. So because multiple things could be in 2 or more different levels, because like if we were to say this 3 can, so from the starting point we can capture these 3 in level 1, and then actually if we use this 3 here, if we take this first jump here, then these 3 will be considered level 2, right? Because jump 1 is here, from 3 to the 3 is the first jump, and then from 3 you can jump to any of these 3, so that'll be considered level 2. So but also if we just looked at this first 3, then these 3 are level 1, right? So these 2 1s are kind of overlapping in both level 1 and level 2, so in like different paths, if you will, like different universes. But at the end of the day, we're gonna have to reprocess some stuff, and in the worst case you might have to reprocess every node. So that's why this will be considered an n squared approach, and I'll show you how we can dumb that down later in order to give us the O of n approach. Actually, I'm not even gonna, let's just scratch this. So I mean, I kind of just already verbally told you how the n squared approach works, so let's just skip straight into the O of n approach, and let's just talk about how we do that immediately. So we're going to have to keep track of jumps, obviously, so we introduce this new variable. So in part 1 we only had one variable, which was max reach, so that's still going to stay the same from before, but we do introduce 2 new variables, the jumps and the range end. So range end is just going to be like the end of each level, and range end, so this is where the quote-unquote greedy takes place. So range end is always going to you know, if we were to have level 0 and then level 1, it'll always range end will always mark the the max possible ending point of that range, of that level. So that's where it's quote-unquote greedy. Okay, so let's see how we can actually do this. So let's reset this. This is like my third time doing it. That's why I have so many numbers here. Alright, so at this 0th index, this is level 0. This number itself, this one number is the 0th level. This makes up everything in level 0. And then, so our max reach is going to be 3 from here, right? Because like we said in part 1, we just add the index with the value at that index. So 0 plus 3 is 3. Max reach is 3. And once our range end is equal to I, so I is 0 and range end is 0, then we'll actually increment jumps and we'll actually update our range end to be whatever the current max reach is, which is 3. And as you can see, that makes sense, right? If you've taken one jump, then your greedy, your best range end is at index 3, right? Because you can look at any of these 3 and the best one is this one. So then we're going to move I again, and then we're going to have max reach updated to 4 actually, because I equals 1 and the value is 3, so 1 plus 3 is 4. And since we haven't looked at everything in this first range of jump 1 yet, you know, because there might be better options in the other latter part of this level, so then we won't update jumps or range end just yet until after we've processed everything in this range, in this quote-unquote level. So that's why we're not going to do anything yet. So then we move I, and then I equals 2 and the value is 1, so 2 plus 1 is 3, so that's not greater than the max reach, so we don't update that. And then so we haven't finished processing that whole first level yet, right? So we move on and then now we look at I equals 3 and then the value is 1, so 3 plus 1 is 4, so max reach stays the same. And then now we actually finish processing everything in this first level, in this jumps equals 1 level, and we know that because range end is 3 and our I is at 3, and so now we can increment jumps to 2. So every time we change jumps, we're only going to increment it by 1. And then range end is always just going to update to match whatever the max reach is, which is right now it's at 4. And let's take a look to try to interpret that in English. So what does that mean? That means if we've taken 2 jumps, our best, you know, the end of that level, of level 2 of jumps of 2, then, you know, the best we can get, the furthest we can get is 4. And that does make sense because the best we can do is go from 3 to 3, so that's jump 1, and then from 3 we can get to the end here, which is 4. And yep, so once range end is greater than or equal to the last index, then you can just terminate early and you just return whatever the current jumps is at, which is 2. So let's take another look and try to do this example again for I'm going to skip this last one, but because of time, I don't want to make this too long, but let's just look at one more example to help you reiterate your knowledge of what you've learned, to help you understand the algorithm even more completely. Okay, so let's reset this. Alright, so like I said, max reach is just going to be the index plus the value at the index, so 0 plus 1 is 1, max reach is 1, and since we're at the range end, so since we've processed everything in the level of 0, jumps of 0, then we can update jumps by 1, and we can update our range end to be whatever the max reach currently is, so that is 1. And then we go here, and so now we can see that I equals 1 and the value is 3, so 1 plus 3 is 4, so our max reach is actually 4 now, and we actually have processed everything in this level of 1. The level is jumps 1. When jumps is 1, that's level is 1, so we've processed everything in this level 1, and so we're going to change our jumps to 2, and then we're going to increase the range end to whatever max reach is, which is 4. So we continue on, and then we look at so I is 2, and then the value is 1, so 2 plus 1 is 3, and so we don't update max reach, and we haven't processed everything in this level 2 yet. Level 2 is everything in this, right? So level 0 is this, level 1 is just this 3, and then level 2 is these 3 nodes. And so so we haven't finished processing everything in this level, so we can't change jumps or range end yet. So we move the I up. So I is 3 now, and the value is 2. So 3 plus 2 is 5. So actually we will update max reach. And so we still haven't processed everything in this level yet, so we're going to keep moving on. And so I is now 4, and then 4 plus 0 is 4. So max reach doesn't actually change. And then so now we realize we did finish processing everything in level 2, so we're going to change jumps to 3, and our range end is going to change to whatever max reach currently is, which is 5. And so now that range end is at 5, which is the last index, the last index number, then we can just return the number of jumps that we currently have, which is 3. And so let's check if that does make sense, right? Because so if we're at 1, then we can take 1 jump to get to 3, and then from 3 we can take 1 jump to get to the 0 here, or no, sorry, 1 jump to get to the 2 here, and then from the 2 we can take the 3rd jump to get to the last index. So yes, so from here to here, so that's 1 jump, and then to get to here is the 2nd jump, and then to get to here is the 3rd jump. So yes, 3 jumps is correct, and so we can return that. And alright, that is the algorithm. My goodness, how many tries did that take me to record this? Jeez. Alright. Please, I hope you guys enjoyed this walkthrough. This took me a long time to put together. It took me a long time to fully understand the question and to fully understand how it relates to breadth first search. And hopefully I did a good job explaining it. I went through the discussion posts on this. I watched several YouTube videos, and I feel like the way that I'm explaining it is as best as I can explain it to my understanding. So hopefully it helps you guys as well. Alright, great. So try to go and implement these yourself now to improve your understanding of the question. And I'll have the code in the description if you want to reference how I did it based on the way that I explained it. And good luck. Alright, thanks for watching.